Okay, so we're going to be using that property where we have two multiplications or two things being multiplied together. Set equal to 0 means one of them is equal to 0. So, sorry, at least one of them is equal to 0. So let's go ahead and look at this. And notice that the right-hand side is not 0 yet. So let's go ahead and make it 0 by moving everything over to the left-hand side. So, let's subtract 24b. So we get b squared. This is going to be minus 6b is equal to 40. And then go ahead and subtract out 40 to both sides. So now we have b squared minus 6b minus 40 is equal to 0. So once you have it in this form, remember we want to write it as a multiplication, and the way we do that is by factoring. So let's go ahead and factor this. Okay, so the factors of 40, see, 8 and 5, 10 and 4. So 10 and 4 are the ones that I want because I want to get down to -6. So always have the variable in the front. And do I add or subtract to get to the -6? So I want it to be negative, so -10 plus 4. Once we have it in this form again, where we have multiplications are equal to 0, you could set each of them equal to 0. So here, b is equal to 10, and here b is equal to -4. Now, what these answers are saying, right, is if I plug them back into the original equation, you'll get a true statement. Now, you can do it in any part that you want. So meaning, I can plug 10 into here, and you'll get two answers, which is, for example, 30 equals 30. Or you can plug it into here, and what you should get out is 0. So that is how you check your answers to make sure that they're 100% correct. So let's continue and do another example. So here, you can factor it with the negative in front, but it's a lot easier if you just pull it out. So I'm going to pull out the -1 first. And by doing that, it changes the signs of all the terms. Now let's go ahead and factor the inside part. And it looks like this, where the variable is in the front. And now the question is going to be, what goes in front of the two ends, and then what goes in the back? Well, the only option is 2 and 1 for the back, because the factors of 2 is 2 and 1. So we have options 8 and 1, or the options 4 and 2. Okay. But in this case, the answer is going to be the 8 and the 1 version, where the 2 is multiplied to the 8, and the 1 is multiplied to the 1. Now I know that because this is 16, and then subtract 1 gives you 15. So let's go ahead and write that. So we need a positive 16 minus 1. And notice that this right here also gives you the -2 that we wanted in the first place. Each of these multiplications can be set equal to 0. So here n is equal to -2, and here n is equal to 1 over 8. Now some of you may be asking, well, why don't I set this part equal to 0? Well, remember, the statement is that at least one of them is 0. So this part right here, which is -1, cannot be 0. So we can just eliminate it already because we know it's not 0. That means that one of these two have to be. Okay, let's go ahead and do that last problem. This problem is, there's one more after this. Let's go ahead and do this problem. It's a little bit more complicated. Let's go ahead and bring everything over to one side again. By subtracting m to both sides. And by adding 3 to both sides. So what we get is minus m plus 3 is equal to 0. So again, it's set equal to 0. And how do we factor when we have 4 terms, right? We factor by grouping. So let's group them by the first 2 and then the last 2. The first 2 we can factor out at m squared, and we get m minus 3. And you can check by going through the distribution. This one over here, I want to pull out a minus 1. And again, factoring out a minus 1 changes the sign. And what they have in common is the m minus 3. So m minus 3 is the multiplication, or the factor. And what goes inside here is whatever's left over. Set each of them equal to 0 again. So here m is equal to 3. Here, we need to solve this by adding 1 to both sides. So we get m squared is equal to 1. Now, once we have this property where we have a square is equal to something, we get rid of the square by using the square root property. So square root both sides. When you cancel the square root and the square, we have to write the right-hand side as plus or minus the square root of 1, or just plus 1 or minus 1. Okay. Now, before we continue, let's look at each of these. The amount of times that this root repeated was once, so it has multiplicity of 1. This root repeated once, so it also has multiplicity of 1. If you notice, all of these actually have a multiplicity of 1 because they only repeated themselves once. Now be careful, don't just assume that. Make sure you check it to make sure that they actually repeated only one time. So this last problem is given by x minus 4 squared is equal to 9. Now, what I want you to notice, right, that we have this property which is the same as over here. A square is equal to something. So we can already square root both sides and get the square root of 9 on the right. And you can solve it like that. There's nothing wrong with it. But what I want to do is show you that you can do it by factoring as well. So what I'm going to do is I'm going to expand this part out as x minus 4 times x minus 4 is 9. And then do the distribution. So x squared minus 4x. Then do the next distribution, which is going to be minus 4x plus 16 is 9. Simplify it. And then, again, bring everything over to the left-hand side so that we can set the right equal to 0 by subtracting. So what you get now is x squared minus 8x plus 7 is 0. This can be factored, and it's factored as x on the front minus 7 minus 1. So multiply these two out, you get positive 7. Minus 7x minus 1x gives you the minus 8x. Once it's in this factored form, set each of them equal to 0. So x is equal to 7, or x is equal to 1. Okay. So remember, you can do it with the square root method. This is just to show, or to reiterate, that we can do it by factoring. Either way is fine. It depends on the situation, right? In this situation, since it's so much easier, you would just square root both sides. But if you were given this one, you wouldn't try to write it in this form by completing the square. You would just factor it and get the same answer.